Hi, today I would like to talk about a problem from the recent CMO qualification exam. The problem itself is not difficult, but I found a pretty simple and elegant solution, so I would like to share with you and hope you enjoy it. Let's start going through the problem first. So an integer number a is given, and we need to prove that for any positive integer n, there exists a positive integer k such that the n consecutive numbers starting from a to the power k plus 1 until a to the power k plus n are all composite numbers. So let's start with the case k equals to 1. In this case, we have a plus 1, a plus 2 until a plus n. So some of them may be prime numbers, some of them may be already composite numbers. So we want to raise the power such that the prime numbers becomes composite numbers. So let's say we have a prime number which is a plus I and call it p. Then it is very easy to find a power such that it becomes a composite number because we can use the famous Neto theorem. So by the theorem, we have a to the power p has the same modulus to p as a. So this means that p will divide a to the power p plus I. And since a is larger than 2 and this is number larger than a plus I, so necessarily a to the power p plus I becomes composite. But now you may say that some of other composite numbers may become prime, so we need to somehow balance this exponentiation such that the composite numbers remains composite. And actually there is a pretty simple way to do that. So the idea is the following. For each one amount a plus 1 to a plus n, we can find a prime divisor. So let's say pi divide a plus I. Then my claim is that if I raise a to the power 1 plus the product of pi minus 1, I from 1 to n, then we get pi divide this number plus I. So this is basically the direct application of the famous Neto theorem. But still we need to be a little bit more careful because there are two cases. So the first case is that pi divide a. In this case, pi divide I. So pi divide any power of a plus I, then it's okay. And the second case will be pi does not divide a. In this case, we can apply famous Neto theorem, which told us a to the power pi minus 1 is the same as 1 modulus p. And in this case, we have this number will be the same as a plus I, which is divided by pi. So this is what we want because we get a single power such that a to the this power plus I is divided by pi, and by the same time they are all larger than pi, so necessarily they are all composite numbers, and this finishes the proof. So hope you enjoyed the solution, and if you like it, don't forget to subscribe my channel. I will talk about more math problems or including some fun math puzzles in my videos. So see you next time.